Hello dear students, we will continue lessons on probability theory today, and this is the lecture 2, practice on elements of combinatorics, classical probability. Here's the lesson plan for today. First of all, we'll continue to repeat arrangements and we'll see some examples on permutation and then combination, and at last we'll see observed and classical probability. Observed probability, it's also called like statistical. Observed, statistical probability. Arrangements. Arrangement of n elements taken k at a time, which is k-fold arrangement of n element, is called any ordered k-fold subset of the n-fold set, which is denoted with the following formula. And here's an example. A group containing 25 students can elect the leader and its assistant by this way, which is arrangement of 25 to. Here the n, the number of students, is 25, as you may see from here, and 25, and then next one, n minus 1, 24, and n minus 1, which is also will be the last term for our exercise, because leader and his assistant, which we have to take 2 students out of 25. We need to take 2 students out of 25, which means 2 minus 1, 1. So we have to stop here for this exercise. 25 times 24, which is 600 ways. Permutation. Permutation of n elements is called any arrangement of all n elements of the n-fold set. We can say that permutation of n elements is the ordered set of all elements of the set M. Here's another example for permutation. 8 books can be placed in a bookshelf by P8 ways, which is permutation of 8 elements. 8 factorial. 8 factorial is the multiplication from starting 1 till number 8. It gives us 40,320. Here are some exercises on arrangements and permutations. The first example says, how many ways can 4 students sit in a 6 seats? So the first exercise, how many ways can 4 students sit in 6 seats? It says, we have to put 4 students into 6 seats. How many ways do we have? For example, the first student can select or can sit any place out of 6. The second student can sit any place out of remaining 5, because one seat is already busy with the first student, and third student can sit out of 4, and the last student can sit out of 3, which is arrangement of 6 elements by 4. So 6 times 5 is 30, times this one 120, 360. So we have 360 ways for the exercise 1. And the next one, exercise 2. How many ways can 6 cars and 2 bikes be arranged in a row without restriction? Okay, 6 cars and 2 bikes. How many elements do I have? It says without restriction, so all the elements like cars and bikes are same for me. According to the question of this exercise, it says without restriction. So first of all, I have to calculate 6 plus 2, which becomes 8, and P8, which is 8 factorial. On the previous page, we saw this 40,320. And last exercise, exercise 3. How many ways 6 phone models be arranged in a row? 6 phone models. It's also permutation of 6 elements, which becomes 6 factorial. Here are the answers for the given exercise there. We try to explain them. Combination of n elements taken k at a time is called any k-fold subset of the n-fold set M. This is the formula for combination. There are 2 formulas for combination. One is using arrangement and permutation. Another one is like the simplified form of combinations formula. Here's an example. One can choose any 4 students of the group containing 25 students to do some work by this way. It says that we have to select 4 students out of 25, and here order is not important. As with the example 1, there we had to choose group leader and its assistant. In that case, order is important. If the first student will be group leader, second will be his assistant. But in this case, 4 students forming a group, they don't have any positions here. So we have to use the combination formula. Here's an example. How many games 15 competitors of a chess tournament must play in one leap? How many games 15 competitors of a chess tournament must play in one leap? And next exercise. How many 6 combination of numbers can be selected from 36 numbers? How many 6 combinations of numbers can be selected from 36 numbers? And the third exercise in this page, which is exercise 6, how many different sets of 4 letters can be selected from the alphabet? Okay, we'll start from the exercise 4. How many games 15 competitors of a chess tournament must play in one leap? This will be a combination of 15 competitors by 2. See, 15, 2. And 15 factorial divided by 2 factorial times 15 minus 2 factorials. And 15 minus 2 becomes 13 factorial. So 15 factorial divided by 13. We can cancel them. 15 factorial means 1, 2, 3, etc. 14 and 15. And 13 factorial means 1, 2, 3, etc. and 12, 13. So we can cancel till this place, till the 14. So in this place we have 14 times 15, and 2 factorial means 2 times 1. So the 14 with 2 we can cancel them. 7 times 15 becomes 105. So we have 105 ways, 5 games will play 15 competitors of a chess tournament. And the next exercise, how many 6 combination of numbers can be selected from 36 numbers? So it's also a combination, 36 numbers by 6, like Sport Lotto here. So we have this amount of numbers. How many different sets of 4 letters can be selected from the alphabet? In English alphabet we have 26 letters, and we want to choose any 4 of them. So we have 14,950 way. So notation for probabilities. P denotes a probability. A, B, and C denote specific events. P of A denotes the probability of event A occurring. Relative frequency approximation of probability, or conducted or observed a procedure and count the number of times that event A actually occurs. Based on these actual results, P of A is approximated as follows. P, number of times A occurred, divided by number of times the procedure was repeated. For example, Mesut Özil, football player, completed 328 passes out of 520. Here's the question: what is the relative frequency approximation of the Mesut Özil's giving pass? He will complete the pass. We have to calculate this P of A, which Mesut Özil completes the event. P is the probability or relative frequency approximation, equals to number of times A occurred. How many times he could complete the pass? 328 divided by how many times the procedure was repeated. How many times Mesut Özil gave the pass? 520. The next one is classical approach to probability. Assume that a given procedure has n different simple events, and each of those simple events has an equal chance of occurring. If event A can occur in S of these n ways, then the probability can be calculated using this formula: number of ways A occur, number of different simple events. For example, when we flip the coin, this is coin has heads and tails. When we flip the coin, we may get one of them, heads or tails. So what is the probability when I flip the coin I will get tails? So probability of event A, which is flipping the coin and getting tails, how many times I can get tails when I flip coin just once? So 1 times. How many possible events? It can be heads or tails, so 1 over 2. And then another example, P of A with the die. The die has 6 sides, like the first, second, third, fourth, fifth, and the 6th side. So it means 6 possible ways. And what is the probability that I will get even number? How many even numbers here? This is even number, this is even number, and this one is even number. 3 even numbers. So when you roll the die, probability of getting even number is 3 divided by 6, which is equals to 1 over 2. 3 is number of even numbers, outcomes. 6 all possible outcomes. Subjective probabilities, the probability of event A is estimated by using knowledge of the relevant circumstances. It's subjective. And here are the examples. The first of all, relative frequency approximation of car crashing in a city, and they're choosing numbers here. And the C is like subjective probability. That's all for today. Good luck, guys. See you in next lectures.